Okay, we're going to do the second part of the parabola question. Here we are. They give you this parabola here. They tell you that's 14.4 degrees, and they tell you that it's tangent to, at t. There's a tangent at t. That means a line that just touches there on the parabola. It's perpendicular to this line here. Okay, now we're going to use it. First, calculate the gradient of AE. Well, gradient is a change in y over the change in x, but it's exactly the same as tangent, which is opposite over adjacent. So all you do is go the tangent of 14.04 degrees, and you get that tangent is the gradient. So the gradient of this line is a quarter. Okay, well, there you go. You've got that. Now it says, calculate the coordinates of t. Well, where do they cross at t? Well, let's see here. This is what we can do. We know that the the gradient of this line right here at t must be -4 because it's perpendicular to the 1 over 4. So all we have to do is turn 1 over 4 upside down and change the sign. You see, the product of those two have to be -1. So you flip it and change the sign. There's the gradient, -4 right there. But we can use calculus. We can take the derivative of 2x squared minus 2x minus 24. That's 2x minus 2. And now if we let it equal -4, you see this derivative is really a formula for finding the equation of the gradient anywhere. And it'll tell me the gradient at -4. If I solve that, I'll get the x value right there where the gradient's -4. And so I do that. I add 2, I divide by 2. The x value must be -1. I put it back into the formula, this one here, -1 into this formula for the parabola, and I get the answer -21. There's the coordinates of t. Now the next question's a little bit tricky. They say a straight line, we'll call it G. It's parallel to AE, but it cuts through some point K, -3 and -9. Actually, it'd be up here somewhere, but I drew it down here. Maybe I'll move it up to make it, because there's -1. This one would be more likely up here at, yeah, let's say there's R, and there's K at -3 and -9. Anyway, something like that. It's parallel. I want to make this line, whoops, I want to make that line just parallel, just like that, parallel to the line AE. And then R is going to go through somewhere here. I don't know, but I know that's -3 and -9. It crosses somewhere over here, but I know that line's parallel. Well, how do I find the equation of this line? Well, I've got a point, -3 and -9, and I know the gradient. It's a quarter, it's parallel. So all I do is use the point gradient formula, and I simplify it, and I get the equation of the line. Now, how do I find R? Well, I've got a line, I've got a parabola, x squared minus 2x minus 24. If I want to find out where they cross, I just let them equal each other. And that's all I do, I let them equal each other. And I solve the equation. Multiply everything by 4, I'll get 4x squared minus 8x minus 96. 4 times a quarter is x. The 4 cancels here. I'm going to add 33. I'm going to subtract x. And then I'm going to factor or use the quadratic formula. One of the answers is x equals -3. But I already knew that one. It crosses at -3 and -9. The other answer is the answer to your question, which is x is 5, 2, 5. And there you go. There's your answer. That's the place where R has to be, the x value. If you wanted to find the y value, you'd put it back into the formula. And that's how it goes.